In this video, we'll look at a few examples of using nature of roots. And so the first example, we've got this quadratic equation, and we're asked to prove that the discriminant, that the roots will be less than 0, which means non-real. And so we set out and we notice that the A, the B, the C are all 1. So B is 1, A is 1, C is 1. So it becomes 1 squared minus 4 times 1 times 1 is 4. 1 minus 4 is minus 3. Because it's negative, because it's less than 0, the roots are non-real. And so we've proved that. The second one, again, prove that the roots are less than 0, prove that they're non-real, which for both these questions visually you'd end up with something like that, a parabola that doesn't have any x-intercepts. That's what means the roots are non-real. And so the first thing that we've got to do is see if there are any other x squared terms. No, so then that would just be our A. See if there's any other x terms. It's just this, so that would be our B. And anything that doesn't have x's, all of it ends up being our C. And so we start not by saying that the discriminant is less than 0. We're trying to prove it, so we literally just lay it out. The discriminant equals b squared minus 4ac. B was k, so k squared minus 4 times 1 times c, which was k squared plus 2. That leaves us with k squared minus 4k squared minus 8, which will leave us with minus 3k squared minus 8. How does that help us prove they're non-real? Like I've done here, just the k squared part will always be bigger than or equal to 0 because something squared is always positive. And so if this is positive, a positive times a negative is a negative. A negative minus a bit more negative will definitely be negative. Therefore, it will be less than 0. Therefore, the roots are non-real. And I hope that was helpful just as going through two basic examples of working with nature of roots. If you found this useful, please like this video, subscribe to our channel, and share it with your friends. Thanks.